Hello, welcome again to our class. Today we're looking at structure query language, that is SQL for you. Remember, SQL is a 4GL programming language. It's not more of a language, but it's created in such a way to make coding much more easier. So we begin with definition of database, though we have basically talked about databases before. So database is a control pool of related data that will be stored with minimum of duplication and redundancy. The key thing with database systems is that we try as much as we can to economize on the use of computer resources. And one of the resources that we are looking at is computer storage. So if the database has a lot of redundancies and duplication, then definitely you're not going to be economizing on computer resources such as the computer memory, and we need a database management system to assist us to do that. Basically, this is the software that allows us to be able to maintain the data in the database, and we have different examples such as MySQL, Oracle, MS SQL, and even your usual MS Access would fall under this category. No, structured query language is a database computer language designed for managing data in relational database language. That is, this language we use it to create statements that would allow us to be able to access the data and to update the data, to delete, and so on. So we have different types of database models. We have hierarchical model, we have network model, we have relational model. Hierarchical model is more of a tree-like structure, where we have a parent can have many children. Again, we have the network model. The network model takes more of an approach where the parent has children, but a child can have more than one parent. So if we have data that has that kind of relation with other data items, then that's what falls under the network model. While the relational model, we basically are talking about tables and how we can use data in the tables and then maybe create a relationship between different tables and so on. We have key terms that we need to be able to remember here. We have relation, which is basically the table that I was talking about. And then the attribute would be what defines an entity. Any component that can assist in defining what an entity is, that can make it actually stand up, like we can have students, and then we have registration number for students, first name, last name for that particular student. Those will be the attribute. So if you store them in a table, then you look at them from the point of column, then those are the attributes that we are talking about. Domain is basically the allowable value for one or more attribute. If we're supposed to have integers there, if we are supposed to have alphanumerics, that's basically what we're talking about. And a tuple would be a row. If you're looking at a table is composed of rows and columns. So if we have attributes being formed in the columns, then if you look at this data from the perspective of the row, then that becomes a tuple. Then we can have degree of relationship, which would be the number of attributes of a constraint. Cardinality looks at the how this data is related. That is, cardinality of relations, the number of tuples it contains. But you can look at it from the perspective of like where we can have relationship between different tables. Where, example, if we have a table for if we have student and we have courses, a course can be taken by many students, and then when it comes to the point of students, a student can take one course, then that will form the cardinality, the relationship that we are talking about. And headings will consist of a fixed set of attributes, and the body, of course, this consists of time varying set of tuples that form that particular kind of grouping. The relations has a distinct name. That's what we need to be able to understand. If it is course relation, if it is a fee relation, if it is a student relation, That is, in that particular database, that must have a distinct name. And also each attribute must also have a distinct name, because we are trying to be able to distinguish or collect data items concerning an entity. So if it is a registration number, then that's the registration number. We cannot have two registration numbers. Each cell of a relation will contain one atomic value. And atomic value is basically the lowest level we can go when we are trying to collect information concerning a particular entity. So values of an attribute are from the same domain. Again, the order of attribute has no significance. It doesn't matter how you're going to arrange them in that particular relation or table, whether the registration is in the middle or whether the first name, you've started with the first name, then second name, whichever order that you follow, it has no impact, because when we are searching through SQL statements, we basically are going to pick those particular attributes from the relations based on how we have defined them on our SQL statement. Now again, we cannot be able to entertain duplication. That's why we're saying a database is a collection of pool of data that has minimum of duplication and redundancy. So we are not going to duplicate, because number one thing, you know that we must have a unique identifier when it comes to that particular content that we have in our tables. And if we have a unique identifier, then it does not allow for repetition, hence no duplication. So the order of rows has no significance again. So that is theoretically, that's what we are saying. Now we have relational keys, and we need to point to note this before we can start writing SQL statements. We have what we refer to as a candidate key. This would be any attribute that can be used to uniquely identify that particular record. However, we might not select it to be the primary key that we are going to use for the purpose of identifying this particular record. Now that takes me to what a primary key is. A candidate key selected to be a primary key. An example is where you have student records. We have set the registration number, and it happens that we also have the ID number of that particular student. So ID number and primary and registration number can all be used for purpose of uniquely identifying that record, and that's why they are candidate key. But since it is a school setup, we may choose to pick registration number as the unique identifier of that particular record. So the registration number becomes the primary key. Now we have a composite key, where we are saying a candidate key that consists of two or more attributes. So if what we have said that we can use to identify that particular record is composed of not just one but more attributes, then becomes a composite key. Now a foreign key would be, an example would be where we have a student table. Now a student table can have a registration number, can have first name, last name, and then it can have course code. Now we can have another table that we are referring to as course table, where course code is a primary key. But now if you look at it in the student table, it is not a primary key, because we have registration number as the primary key. So in that example, the course code in student table would become a foreign key, and that's why we're saying a foreign key is an attribute in one relation whose values are required to match those of a primary key in some other relation. And when I said when we are talking of relation, we're basically talking of tables. We have entity integrity, which is very important. No attribute participating in one primary key of a relation is allowed to accept a null value. We cannot have, you've said a registration number example to be the primary key, and then you're trying to store a record in your table that does not have an entry for registration number. That will not be possible. Referential integrity: if a foreign key exists in a relation, either the foreign key value must match the candidate key value in the home relation. So we cannot have our, in that example I gave you of student record, where we can have a student table, but in this student table we have course code. So the value that you're going to enter in that course code must be a value that already exists in course table under the course code attribute. So you cannot introduce a new value that does not exist in the original course table. Hence, that is the referential integrity. And remember, null, we have said, represents a value for an attribute that is currently unknown or is not applicable in this tuple. So if you don't make an entry, and then that will be the null that we are referring to. Now, enterprise constraints, we look at additional rules specified by user of a database. A user or a database administrator can be able to set other restrictions, and these restrictions may be as a result of maybe who can access a particular kind of data item and so on. So those will be enterprise constraints. Then we have domain constraints themselves, a restriction on the values that are allowed for a particular attribute. If you expect to have integer values for maybe course code, then they should always be integer values. That is, the database should be designed in such a way that it will not allow any other entry. Hence, that will be a constraint. Now we still have different examples of relational database. These are relational database management system. We have MS SQL database, MySQL. We have Oracle, Postgres, and then DB2, and many others. There are so many of them out there. So once up and running, we are going to cover three main categories. That is, once we start now coding, we'll be looking at SQL from DDL, the statements used to create, modify, delete database objects. So those particular kind of statements, we refer to them as data definition language. We have those that are used for manipulation, that is DML, and these are used to insert data and manipulate the data. You can make some changes in that particular data, so that will fall under DML. We have data control language, statements used to group statements together and control database transactions. So whenever you're working with unions and all that, so that will fall under data control language. We say SQL is different to other languages. So before you start writing it, let's just, okay, basically what we're trying to say here is that, as I said before, SQL isn't a complete language. That's why it falls under 4GL. So if it is a 4GL language, it's a language that you use with other programming languages. Like those people who are involved in web development. Like example, if you're working with PHP, you'll find that you're going to have to insert your SQL in your PHP codes and so on. So that's basically how you'll have to work with it. Now, what are advantages of database? It brings about independence, efficient data access, because we basically just use database systems primarily for purpose of sharing data. We have data integrity and security is another thing we must be able, that is, your database management system should be able to support that, because data that is in a common pool that is being accessed by many people need to be protected. We have data administrators who have the duty of ensuring that as they manage data in our database systems, that they can ensure that this data is accessed by the right people. Now, let's start looking at the SQL. Now, example, we have code here. To check the version of MySQL, we'll be using MySQL for coding. MySQL is an open source database management system, and for that reason is the best one to use for that particular this particular tutorial. So using SQL, let's check what this code is going to give us. We expect it to give us the version of the MySQL that we're using. I've already installed MySQL in my computer system. Therefore, let's have a look at it. So basically we have select, let's select, and then the version. Yeah, so it tells me that I'm making use of MySQL version 8.0.31. So after you install MySQL, the next probably wonderful things that you after you installed MySQL, the next thing that you can do is, of course, you're installing it for purpose of creating a database. And if we were going to go straight away and create a database named, we can call it students or school. School would be much more appropriate. So it's basically just create database, because you must be able to mention what it is that you're creating, and the name is school. School. Once you do that, always make sure you terminate before you press enter. So query OK says that it has been created. Now, since our database has been created, the next thing that we need to do is work on it. And for us to be able to work on this particular database, what we need to do is to use this particular database, get inside the database and make use of it. So how do we go about it? Now, you basically use, and then the name of the database is school. There you can see database changed. Now it has changed to our database. So, and from now on, any instructions that we are going to be giving the computer, any statements that we are going to be writing will be directed to our database school. So we are saying that after you've created after you've installed your MySQL, the next thing is to create a database and then create tables and then begin to insert data. Now you've seen from that example that we've been able to create the database using the SQL statement given here, create database and then the name of that particular database, and we've been able to get our query OK. Now we say that the next thing that you needed to do was to use that particular database. You need to go inside the school database and then begin writing your statements for either creating tables and so on. So it will only work, you can only create a table when you are inside database school. Now, here's an example of a table that we can create. We can create a table that, we have a table here with registration number, student name, sex, course code, and date of registration, and Y or B would be year of birth. Now, if we look at it, we have different types, and then we have size, and then we have primary key. We are trying to set the registration number as the primary key. I think the labeling of the table headings are not correct. So we are supposed to have another line there to show us we have registration number, and this is the particular type of that registration number, the size, and then we indicate that it's a primary key. So how do we create this table? Now, to create this table, we basically say create table student. We must mention what we are creating. We are creating a table. In our previous example, we are creating a database. That's why we say create database. Now we are creating tables, create table, and then the name of that particular table, create table students. Then now we get into the fields of the attributes. We have registration number, which we can give a size of maybe 5, and then you can say not null. And then we have student name, we can give a size of 30. And then we have sex, course code, date of registration. That one can take a timestamp. Timestamp is that the system will automatically assign the current date of the system as you are entering that, as you begin to enter data into that particular record. So you not need to enter data for date of registration. Year of birth, we have set it year and not null. That is, when you say not null, we basically expect that record to only be stored when we have set a value for that particular attribute. Then you can say primary key is the registration number, because we are saying we want the registration number to be the primary key to be the registration number. And then lastly, you can close that bracket and you terminate. So let's go ahead and see how it will work. Create, then table. One thing about SQL is not case sensitive. We have students, then you open our bracket there, and then you can continue typing in a single line, or we can press enter. We have registration number, voucher, we can say to a size of maybe, let's have it 10. Yeah, let's have it 10, and then we say not now. Then a comma to separate so that we can move to the next attribute, which is student name. Though it's not case sensitive, it's just trying to be uniform. But what size? Maybe 30. Yeah, that can work well. Then the next one will be sex or gender. Then voucher, we can give it 6. Let's say either male or female. That's what we are looking at it from that perspective. Then we have course code. We can set the size of course code to be probably 5. This depends on what you're working on. Then we have date of registration. We can set it as timestamp, and then we say not now. Yeah. Then we have the year of birth, Y of B. Year of birth, you can say its type is year, and it's also not null. And lastly, we must be able to say which one is the primary key. Primary key should be the reg number. And then we can close it, and then we terminate, and then let's press enter and see we can get a query okay. There it has been created, query okay. We can confirm whether it has been created by saying show tables. Is it tables? Let's try and see. Yeah, show tables. So it's tables in school. School is the name of our database. So we can confirm whether the table has been created by show tables, and it has been created. Now, having seen that our table has been created, so the code has no error, that is, the SQL statement is okay. Now, you can also alter table. Alter table statement is used to add, delete, or modify columns in existing table. We can have alter table, and then the name of the table, and then add, and then the column and the type. That's if you want to add a column to that particular table. Now, let's look at it from this perspective. Here we have our table. It has registration number, student names, sex, course code, date of registration, and year of birth. Now, we are not going to add course code because we already have it, but this is an example how we would do it if we wanted to add course code. It's basically alter table, then you specify the table that you want to alter, and then add, and then the course code is what you're going to have to add. Now, if we wish to delete or drop If we wish to delete, we basically say alter table and then the name of the table, drop, and then you drop a column. Now, for instance, let's assume we want to drop the course code. Describe, we can use describe students. Now, describe students allows us to be able to see this particular table in SQL, how we have created the field, the type, whether it is null, which one is the primary key, can be able to show you all that. Now you want to get rid of course code. You want to get rid of that column. So we said what we basically need to do is to alter the table. So it's alter table, which table? Students. That's what we're going to alter, and then we're going to drop. What are we dropping? Column. Which column? Course code. Let's see how that works. Okay, it has worked. So to verify whether it has worked, let's go back and describe the table. There it is. Now, as you can see, we have an updated student table, but this student table is lacking course code. Now remember, we said that if we want to add course code to our table, now we can test that command, the alter table student, and then add course code ID. Let's test it and see if it's going to add our column. So we have alter table students, add just course code. Then we can say maybe virtual, maybe course code can be, let's set it 5 as it was. There. Now let's run it again. Let's do describe and see if we are going to get the original table. Describe students. There it is. It has been added. Now we have seen how we can be able to work it out, how we can be able to alter, drop, and all that. So basically, alter is very important in SQL. If you're working with alter, you can be able to achieve a lot. You can be able to make changes on tables that you've probably added columns that you did not want to work with, or you've decided that you need more additional columns to a particular table that you've already created, rather than going to drop the table, rather than deleting the whole table and starting all over again. So, and this tells you that for you to be able to get rid of a table that you no longer need, you basically just need to say drop table and then the name of that particular table. So in this example, we are not going to be dropping our table. We are going to work with it. Now again, if you wish to change the name of a column, we basically talk of alter table and the table name, and then alter. You specify the column that you're going to alter, and then give the name and the data type. Here we have example alter table. You give the name of the table, then we have rename student. Now this can allow you be able to change the name of that particular table, but we are not changing the name of our table. That's what we would like to work with. Now we have demonstrated the use of describe, and we have said once you have created your table, you can use the following statement to view the structure of your table. So we did describe student, and we were able to see our table, how they were created and all that.